Hello, guys. Good evening. I hope everyone is doing good today. So, I'm glad to be back and to bring you all the data engineering series. I have had an amazing response from all of you for this data engineering series. And if you have been following us regularly, you know that we didn't take a break, but we just focused more into Python. And that's why we were learning with our Python series. And if someone is new here, please do check on our Python series as well. We have already at least like somewhere around 5 to 6 videos, and we have started from the scratch. So it's more of less like an interview based learning. So it'll be very beneficial to you. So do check on that. And then this is our data engineering series. And thank you all for amazing response. I'm really grateful for all this because I didn't expect when I started this I would get such an amazing response. And the core reason being my priority wasn't about the views, but it was more about knowledge sharing. So I want to make sure that the knowledge I've gained from the industry and especially within the data domain, I want many people who want to get into the industry because there are a lot of people who are aspiring to become a data engineer, but it's still it's the education is not accessible in a very easy way. So I find this medium, the YouTube medium, to be very very beneficial to our company's cause as well. So at Data Valley we believe that education is something that need to be provided to all individuals so that they can become brighter in their career, in their lives, in whatever aspects they are looking for. So without further talk, let me introduce the company. We are Data Valley, and we are the fastest growing edtech company of 2025. If you haven't checked on our channel, go visit our website. You'll be having a good idea about what we do and how we can help you to become better in your career. And do follow our Data Valley Tamil and Telugu channel as well because we provide regional based learning as well. And talking about DATAVALLEY-INC, this channel, if you like this content, feel free to give a thumbs up. And if you have any questions, drop your questions in the comment section and do share it with your friends who are aspiring to become a data engineer. So this will be very beneficial to them. And that's it for today. So we will jump to our video. And myself, Franklin, I have almost 3+ years of experience as a data engineer. And you all know that what you have to do. Grab your notebooks, grab a cup of coffee, and make sure that you pay attention for at least next 45 to 1 hour. This is very important video today because these are certain things people generally don't teach. These are general things where people don't pay much attention. But you might be a pro data engineer or you might be trying to become a data engineer, but these are real time and in demand industry questions which you'll be practically using in your workplace. So make sure that you pay attention to this. And today we are starting our data engineering series 6. And unlike our other videos, I'm not going to have multiple domains to be taught. So usually our template goes like SQL, Python, PySpark, ETL, cloud tools. But today I just want to cover SQL and Python and make sure that you pay so much attention to all of these because these are very crucial not only for your interview but even if you're in your workplace. Right? So the first question for today is, how do you use common table expressions for recursive queries? What do you mean by recursive queries? So recursion means looping. Recursion means something that you do again and again. It's a process of iteration, right? So how do you use common table expression? So what is a common table expression? If you have been following our videos, you'd be pretty much sure about it. So common table expression is a form of creating a temporary table, right? So you use CTE to make a temporary table. So instead of having a physical table and then querying it, you create a temporary table. So that is how you use CTE. And talking about recursive queries, so from the question, you can try to get a bit of an idea. So you want to run a query, which is a recursive query, and you want to use a common table expression. By using both of these, you want to benefit from that. So how do you benefit? What benefit do you get? And how do you use it? So that's all we are going to cover in our first question. So by definition, recursive common table expressions in SQL allow for the execution of a query repeatedly. That's what recursion means, right? So a query is going to be executed repeatedly, referencing its own output in subsequent iterations. So whatever the output that you're getting, you're going to iterate through it, and from that output, you're going to get another iteration as well. And this is particularly useful for handling hierarchical data such as organizational charts or bill of materials, and for generating series. So what do I mean by hierarchical data? So for example, if you consider a school, how does an hierarchy work out there? You'll be having a correspondent, and then under him you will be having a principal. Under the principal you'll be having an headmaster or a headmistress, and then under headmaster you'll be having your staffs, and under the staffs you'll be having your students, right? So your hierarchy goes from your top to your bottom. Similarly, to handle those kind of hierarchical data or organizational charts, you use recursive queries along with your common table expressions. First, let's see the structure of our recursive CTE. The recursive CTE consists of three main parts. The three parts are: you have an anchor member, you have an recursive member, and then you have an termination condition. So what are these three parts? So the anchor member is the initial or the non-recursive part of the query. So what do I mean by initial and non-recursive part? So in a recursive CTE, as I said earlier, you have two members called the anchor member and the recursive member. To give you a broad idea, so anchor member is where your loop begins from, your iteration starts from. But once it has been started from your anchor member, it is further looped to your recursive member, and the iterations happen in your recursive member, and then for each recursion you get an output, and this output must meet with a particular termination condition. And as long as the output hasn't met your termination condition, the iteration keeps on continuing with your recursive member. So this is how your recursive CTE functions. And as I said earlier, this is where your initial and your non-recursive part of your query is, which is our anchor member. This has our base result from where our recursion begins, and it does not reference the CTE itself. So what do I mean by it does not refers to the CTE? So in the anchor member, you're going to run a SQL statement, and you're going to have certain columns defined from your table. And this table is from the initial table or your original table, but not your CTE table, because CTE table is something of a temporary table that you create for your recursion. So this recursion, because recursion is not happening in your anchor member, it doesn't use your recursive table. And then you have got recursive member. So this part of the query references the CTE itself. So for this purpose, for in the recursion member, you are not going to use the initial table or your original table, but instead you are going to run your queries against your referenced common table expression table itself, which in turn allows for the iterative execution. It typically performs an operation, example like adding a value, joining to a related table, based on the results of your previous iteration. So for each iteration, you're going to get an output, right? And these outputs will be matched against the recursion, and on the each recursion, you're again going to get an iteration, and with the iteration, you'll be getting a new result again and again. So basically, what I'm trying to tell is, for each iteration, you're going to get an output. The recursive member is combined with an anchor member using union all. So what do I mean is, you're going to have the anchor member at the top, and then you'll be having a recursive member at the bottom. So for these two members, you're going to have a member statement, or a statement that would unify them, or a statement or a keyword which is going to combine the values from both of the tables. So how do you do that? You can use union all. Union all is the one that is widely used, but instead of union all, you can also use other keywords like union, intersect, except. So these are the other keywords that you can use along with your common table expression. And then you end your recursion with a termination condition. So the termination condition is going to have a value which, when matched with the recursive result, it is going to end your iteration. So as by the definition, the recursive member must include a condition that eventually terminates the recursion, preventing an infinite loop. This is usually achieved through a where clause that limits the number of iterations or the values being processed. So you're going to achieve your termination condition by defining a where keyword, and then you're going to specify the suitable number of iteration or the particular value that you're looking forward to process. And here I've got the sample syntax. So for CTE, you know that the initial statement is with CTE name as. But in recursive, you have to use a keyword called recursive. So pay attention. This is the difference between your CTE and your recursive CTE. For recursive CTE, you need to specify the keyword recursive. And then with the open and your close bracket, inside which you'll be having your anchor member and your recursive member. Talking about your anchor member, as you see initially, this is your starting point and where you're going to have your initial base query value. So here I'm selecting my columns from my original table. So I'm not choosing it from my recursive table, but rather I'm choosing it from my original table. And then I've got my initial where, and then we are merging both of the results by using keyword called union all. As I said earlier, you can use different keywords as well, which includes union, except. So these are the few keywords that you can use instead of union all, but union all is the one that is widely used. Please be reminded of that. And then you have your recursive member. So in the recursive member, you can reference your CTE, which is, in this context, it is CTE recursive name. So this is our temporary table name that we have kept for this CTE. So what I'm doing here, I'm choosing the column from my recursive CTE or my CTE basically, and then I'm giving an alias as well. And then I'm running here a join function, and for joining I'm using a different table that is not of my original table or my CTE table. So I'm trying to combine it with a different table called another table, and then here is my on condition which we are going to evaluate the match. So from the CTE.sum ID, I want to match it with the another table with the some other ID. And here is my where condition, which is going to be my termination statement. So where termination condition, so I can specify any condition. So I can even specify the number of loops, or I can specify the key value that I'm looking for. And then from my CTE, I can select my outer query where I'm running select star from CTE recursive name. So the key difference is you're using the keyword called recursive, and also you can choose particular columns from your recursive table. And here are the key considerations. The recursive keyword must be included in the with clause when defining a recursive CTE. So whenever you are trying to create or work on a recursive CTE, make sure that you specify the keyword recursive. The column names and data types in the anchor member and the recursive member must match. So whatever the column names and the data types that you're mentioning in your anchor member, make sure that it is as same in your recursive member as well. The recursive member must eventually produce an empty result set to terminate the recursion. So what do I mean? So with each iteration, you're going to produce a certain value or an output. And there must be a point in your iteration where you don't produce any output at all, which then there is going to be an initiation for your termination. Unless there is an empty set coming out or empty result coming out, you can also specify your termination condition, which will end your recursion. Also, be mindful of your potential infinite loops. If the termination condition is not properly defined, some database systems have a maximum recursion depth up to prevent this. So what do I mean by be mindful of your potential infinite loop? For example, when you run a while loop and when you don't specify your termination condition, what happens? Your while loop keeps on running and eventually there might be chances that where your system crashes out. Similarly, recursive CTE, make sure that you specify an termination condition. But in some database systems, there is a limit for maximum recursion depth, which is prevented by default. But you as a programmer or a developer, be sure about where your code must terminate. Explain the difference between inner join and cross join. We all know about inner join because that's what we have previously covered in our previous series. But in this, let me explain. And here what we are discussing is the difference between the inner join and cross join. So talking about inner join, what do you do in an inner join? You have your two tables. And with the two tables, you specify the keyword inner join. And then based on the match from both the tables, you get only the matching rows as your output. For instance, let's say I have my first table that has values A, B, C, D, E. So I've got 5 rows. And then I've got my second table, which has 3 values, A, C, and E. And when I try to run an inner join, the matching values between the first table and the second table are A, C, and E. B and D are ignored because there is no match for it in both of the tables. So my query output would be ACE because those are the matching values from both the table. Okay, let's see it by definition. The fundamental difference between an inner join and a cross join in SQL lies in how they combine rows from 2 or more tables. So the difference is how they combine the table. So in any type of join, you're basically trying to join the table, right? But the difference between all types of joins is how they join. So if you, in case of right join, you're going to give priority to your right table. In case of your left join, you're going to give priority to your left table. So similarly, the priority or how the joins work. So how is the keyword that you need to remember how the inner join and cross join differs? So with inner join, it combines the rows from 2 tables based on a specified join condition. So with the inner join, you're going to have an specified join condition with which your matchmaking is going to be done. And it only returns the rows where there are matching values in the specified column of both the tables. So as I said earlier, if you run an inner join, the matching values would be A, C, E. So these are the common values between both of your tables. So it only returns the matching value. It effectively represents the intersection of 2 tables based on the join condition. So it is an effective representation of a common intersection of the 2 tables. All right. So I've got a sample syntax here. So I'm running a select statement against. So I've got my original table, the employees. So with which table I want to run a join? Departments table. And then as you can see here, I've got the keyword inner. So remember that you have to specify your inner keyword. And then I'm specifying my matching condition. So I'm specifying on which condition I want you to do a match. So employees.department ID is equal to departments dot department ID. So department ID is the common column between the employees and the departments table. So you're running a match, and based on the match, you're going to get the output. So this is how your inner join works. But cross join is entirely different to your inner join. Be sure about it because there are chances that you might be getting this in your interview. So how does a cross join differ from inner join? Okay. First of all, before knowing the difference, I want you to know that there is another name for cross join. The other name is courtesan join. So in the interview, they might ask you, can you explain courtesan join? So you should not be wondering, oh, I followed Franklin's data engineering series and he didn't mention courtesan join. So pay attention. The other name for your cross join is courtesan join. So what do I mean by a cross join or a courtesan join? So in a cross join, what happens is you are getting a courtesan product. So what do I mean by a courtesan product? I'll come to that later, but just know that you're getting a courtesan product. So whatever the table is involved, you're getting a courtesan product. It combines every row from the first table with every row from the second table, regardless of any matching values. So what do I mean by that? Let's say I'm combining rows from the first table against my second table. Usually in the inner join, you have your matching value, right? Only with your matching value, you try to do your inner join. But with the cross join, your matchmaking doesn't matter at all. So you might have your match, you might not have your match, but it is very irrelevant in the context of cross join because what's going to happen is you're going to get a courtesan product. You might be asking, okay, bro, what is courtesan product? You haven't explained it yet. Yes, I'm coming to it, but just remember that you're getting a courtesan product. So what happens is if the first table has A rows and your second table has B rows, the result is A cross B rows. What do I mean by A cross B rows? So the other word is courtesan product. What is a courtesan product again? Okay, now I'll explain that to you. As you see here, let's say I have 10 rows in my first table and then I've got 5 rows in my second table. So by the formula A cross B. So if I multiply 10 is to 5, it'll be 50 rows. So for a table of 10 rows and a table of 5 rows, my courtesan product would be 50 rows. So courtesan product is nothing but it is all the possible outcomes that you can get for your input value from your table. So no matter, for example, let's say I have 100 rows in my A table and 10 rows in my B table. So my output would be 1000 rows. And those 1000 rows are my courtesan product. Again, you might be wondering, how is that possible that I get 100 rows? Let me make it in a very narrow way so that it is very easier to understand. Let's say I've got my first table with 1, 2, 3 values and my second table with the values A and B. The courtesan product would be against A and B, right? So A cross B. So what's happening here is for my 1 from my first table, I cross it against my A, which is my first value in my second table. So what happens is, let me try to put in the code. So here is my A table, which has 1. Then I've got B table, which has A, comma, B. So these are my table values. So what happens with my courtesan product? So my courtesan product would be, so what I'm trying to tell here is that there are chances that you get all the possible outcomes for your value that you are provided. So by definition, A cross B, so A has 3 rows and B has 2 rows. So the outcome should be A into B is equal to 3 into 2, which is 6. So as you see here, I've got 1, 2, 3, 4, 5, and 6 values. So that is your courtesan product. I've got a table here for you to understand it better. So I've got a table called color and I've got a table called size. Color has two values, red and blue, and size has four values, small, medium, large, and extra large. So as you can see here, my Cartesian product is going to be all possible outcomes. So for red, I've got small. For blue, I've got small. For red, it goes against medium. Blue, it goes against medium. Red cross large, blue cross large. Red cross extra large, blue cross extra large. So A cross 3. So 2 into 4. I must be getting 8 rows as my output. So as you can see here, I've got red small, red medium, red large, blue large, red extra large, and blue extra large. So this is your Cartesian product. Okay, there are a few considerations that we must look as well. But before that, let me explain you the syntax as well. So I've got my select statement from colors table and cross join size. So cross is my keyword here. So for inner join, you use inner. For cross join, you use cross. And then importantly, for inner join, you were using the on clause. But with your cross join, you don't use your on clause because you're just creating all possible outcomes irrelevant of your matching or non-matching values. And then I've got what is indexing? How does it benefit the performance? So indexing in database is a technique that significantly improves the speed of data retrieval. So the main first thing first, indexing is a strategy that you use to increase your performance. All right. Okay. Now your question must be, okay, how does it improve your performance? Okay. So it helps you with the faster data retrieval. And now your question must be, okay, how does it improve my speed of data retrieval? Okay. What happens is that it works by creating a separate sorted data structure that allows the database to quickly locate specific data rows without having to scan the entire table. So what happens is that when you try to index a column within a database, it creates a separate, a sorted data structure, and it is stored within your database. And when you try to run a query, what happens is that it tries to locate the specific data rows based on the index rather than your full table scan. In short, if I have to explain, we all have the habit of reading books, right? At least let's say you don't have the habit, but in the school you would have used your books. Let's say I need to look for the chapter called Python, and instead of going through each page one by one, what I would do, I would go for my index page, which is going to say that the chapter that you're looking for is in the particular page number. So for instance, let's say I want to access the Python chapter. So it says that Python is located at the page number 30. So I just can go directly to page number 30 instead of going through page by page and looking for, okay, where is the Python chapter? So I hope this is very clear, isn't it? So you use indexing concept as similar in your textbook, in your database, to retrieve your data faster because you are providing a way to quickly access the particular data location. Now let's see how does it benefit our performance. First, it helps us with the faster data retrieval. And how does that work? Because when you index, the database can quickly navigate to look for the relevant data. So as we saw earlier, the Python chapter is going to have a certain page number. And by using the page number, I can look for the particular particular chapter. And it is very easier rather than me going through one page by page. Similarly, instead of a full table scan, what's happening? I know where the location is and I'm going to fetch the data straight from the particular location, with which we are reducing the time needed to process the data, and therefore you're saving your performance and your time. Imagine I have a 500-page book and I want to look for Python. So If I don't have index page, I have to go through each page number, right? But if I have the index, I can go straight. Similarly, with a database, when you have index, instead of going through all your data, or in other words, instead of performing full table scan, you can just go straight to your data by quickly navigating. Second, it improves your query performance. How does it improve my query performance? You all know that it is avoiding the full table scan. Therefore, you're fetching the data straight from the location. So, as on top, let's say I have 2 GB size of a table. If I'm scanning the 2 GB size of data, it is going to cost me my time and my performance. So now what's happening here, because I know the location, because my data has been indexed, I can just fetch it directly, therefore improving my query performance. Then it is reducing the resource usage. Okay, let's talk about the resource usage. When you're trying to fetch a data, you initialize your resources, right? You initialize your memory. So all the data is going to be loaded. It has to look for each data or item by item. And now, because I know the location, I'm not doing a full table scan. If I have a 2 GB size of a table scan, imagine the memory or the CPU or the input output usage that would happen to fetch that data. But because I have indexed it, I don't have to do full table scan. I just have to go to the location straight away, fetch the data. Therefore, I'm limiting my resource, therefore reducing my resource usage. Fourth point is enhanced stability, or enhanced scalability. What do I mean by enhanced scalability? Let's say your database, you start with 2 GB data size, and every day with the transactions happening, your data size is going to grow, which in turn is going to increase your database size. No matter what, how your database grows, because you have indexed your particular data, you don't have to perform full table scan. So though my database could grow, which in turn is scaling out, my performance is not compromised because I'm fetching the data wherever I need it based on my indexed values. And to our next topic, so to our Python section, the first question is, what is the role of generators in processing streaming data pipeline? So generators play a crucial role in processing our data pipelines. And especially with the streaming data pipelines, you have to use generators to make sure that your processing is well and good. You don't have any problems. You save your you save your data pipeline being broken. So there are multiple functionalities that you need to work on so that you benefit by using generators. We will list out all those efficiency and our benefits later, but just know that for streaming data pipeline, it helps with the memory efficiency and lazy evaluation process. What is memory efficiency and lazy evaluation? We will talk about that, but for now, to know that the generators help you with the memory efficient and lazy evaluation process. All right. They allow for processing data on demand, one item at a time, rather than loading entire data sets into memory. Still, I'm not going to talk about your memory efficiency and lazy evaluation. I'll talk about it, but I will try to draw a bigger picture from which it'll be easier for you to understand what's happening with your memory efficiency and how is lazy evaluation helping you out. So what's happening with your generator is that you process the data only that is on demand. So how is this on demand data created? So let's say you're streaming a streaming pipeline is generating a data, and you're getting a data. Okay, so you're processing on demand data. That is, you're processing the data that is applicable or available at that particular point of time. First things first. Secondly, though the data is on demand, that is, though there are chances that you might get a large quantity of data at the same time, instead of processing all the data on demand, you're processing one item at a time. And then, no matter what, even if you load the entire data set, what's going to happen is your generators are going to process your data one by one. So it doesn't, load all your data set straight into your memory, but one item at a time. And this is particularly useful when dealing with large or infinite data streams. What do I mean by large or indefinite data streams? In streaming pipeline, one thing is for sure. You're not going to get a defined size of data per transaction. So because what happens with the streaming pipeline, there are chances that multiple transactions happen simultaneously. So at a time you might be getting a larger quantity of data, and then sometimes you'll be getting just you know infrequent lower data quantity. So no matter what, you're going to process them one by one. So the size doesn't matter. If it is on demand, doesn't matter. Even if you load the entire data set into your memory, it doesn't matter, because you're storing and you're going to process them one by one. Because let's say I'm storing a huge volume of data. If I have to store them and I have to process them in one go, it is practically impossible, because that is when your memory efficient problem come into play. So now I'll explain what is memory efficiency. We all use a mobile gadget, and let's say you have opened all your apps within your phone. There are high chances that your RAM is full, that is, your processor is full, and then your system is going to hang and your performance is going to be lower. So if you use generators, instead of having all your applications run at the same time, with generators, it spends or it processes one item at a time, or it uses all the RAM processing speed for one application at a time rather than all the applications that you have opened in your mobile phone. In Python context, it allocates or it processes one data file at a time rather than processing all or one big file in a one go. Generators produce values one at a time using the yield keyword rather than storing them all in a list or other data structure. This minimizes memory usage, especially when working with massive data sets or continuous data streams. So, for using generators, you use a keyword called yield. So, what happens with the yield is that you are going to process one value at a time, okay? And then instead of storing them all in your list or in a particular memory or your data structure, you will be processing one step at a time. And how do you do that? By using the keyword called yield. And then we have a concept of lazy evaluation. As I said earlier, we'll be looking into it now. So lazy evaluation is when your generators only compute the next value in the sequence when it is requested by the next stage of the pipeline. So as long as your further series of pipeline requires a particular stage to happen, your generators wouldn't process the particular sequence. This just means that if a particular value is needed, it's never going to be calculated, therefore saving on your processing time and your resources. So with each iteration, you're going to get a certain value. Or let's say with each sequence, you're going to generate a value. With when you use the keyword called yield or when you use generators, if a particular step or a particular value is not going to be used further, your generators would not process them in first place. Therefore, lazy evaluation comes into play. So instead of working out on all the values or all your sequence, it just processes the steps or the value only that is necessary for your further step. It also provides us with composability and modularity. What do I mean by composability and modularity? By using generators, you can easily combine and chain together to create a multiple complex data processing workflow, like building a pipeline of different processing steps. So, talking about a complex workflow, you're going to have a different processing step, right? With different processing steps, what you can do is you can use generators to combine and chain all these to create a complex data processing workflow. Okay. The reason is you might be worried if I process and chain all my complex data, it is going to cause memory efficient issue and it is going to create an error and break the pipeline. But that is where your generators come into play, because generators process one item at a time. Therefore, there is no chance for you to have a memory inefficient issue. And then, talking about readability, generator based pipelines can be more readable and easier to understand than traditional imperative data processing code, especially when dealing with complex logic. So, what's happening is, so you're going to get a better readability or better readable feature for your code, because it is not like the traditional imperative data processing code. For example, in your traditional code, you might be using words like return, and you have different forms of writing your code. But especially talking about a complex logic, it provides you with better readability because, as you have seen earlier, it helps you with the better composability and modularity of your code as well. And I've got an example here. Imagine processing a large log file. Instead of reading the entire file into memory, a generator function can be used to read it line by line. So, as I said earlier, yield is a keyword that you use to process a large log file one by one. So, I've got a code here. So, I've defined a function called read log files. Then I have defined my file path as well. So, that is my argument, which is the file path. And then I'm using my code with open file path as or. So or is going to say that I want to run the code in the read mode. Okay, I want the file in the read mode. And as f is the alias here. So for the file here, okay, for with open file path or as f. So f is my alias for line in f. So for this file, okay, the file that I opened in the read mode, I'm saying that go by line, and then I'm saying yield line dot strip. So what's happening here is, instead of reading my complete file, so whatever I have provided here, so this is my complete file, right? So instead of processing that as one single file, what I'm trying to tell, yield line by line. So each of your line is going to be processed individually. Talking about a traditional coding, we use return keyword, right? So what does a return keyword do? It's just going to give you all the output, whatever the input that you have provided straight away. But with the traditional coding, you can return only what is, but with the yield, you just generate one item at a time. So therefore, you're not going to have any memory efficiency issues. So I've got an example usage here. I've got an object called log lines. Then I'm using the function called read log lines. And here is my file name, okay, which is going to be my file path argument for log in log lines. So log lines is my object, right, or my file name. And then I'm saying process by each line. And this is going to process line by line. And why is that? because my function has already used yield function here. So I don't have to worry about, mentioning yield line here. So it is going to print one by one rather than printing the complete full file. So this approach allows you to process the log file without loading the entire file into memory, making it suitable for very large files. Furthermore, you can usually add more generator functions to the pipeline to perform further processing, such as filtering, transforming, or analyzing the data. Okay, so the key point here is that you use generator to avoid memory efficiency issue and to promote lazy evaluation. Therefore, you are going to process your file individually one by one rather than forcing the full read and then causing processing issues. And then one thing is, you can use generators individually for each of your pipeline processing, like for different transformations or filtering. Therefore, you're making sure that your pipeline is consistent and reliable. Okay. And then, how would you handle exceptions in Python ETL workflow and ensure the pipeline doesn't break? So these are the few, you know, uh, okay, I'll talk about it. But before that, what is an exception? So exception is any kind of error that you get in your Python workflow or your pipeline workflow. For your Python ETL workflow, there are going to be chances that you'll be getting an exception or an error. Okay. So when an error occurs, what happens is it disrupts your normal workflow or your normal pipeline flow. And exception signals that an error or an unexpected condition has risen, and we are going to handle that unexpected condition or the error that has been forwarded out. Why are we doing that? Why should we handle an error? The reason is very simple, because when the error is not handled out, your pipeline is going to break. So make sure that you handle the exceptions, or in other words, you handle your errors so that you don't break your pipeline. Handling exception in the Python ETL workflow is crucial to ensure pipeline stability and data integrity. So make sure that you implement exceptional handling methods in your workflow so that your pipeline doesn't break and it is stable. The first approach is try except block. We all would be aware about try except block. So try block is going to have your error prone code. Okay, so any code where you expect some kind of errors, so you put that in your try block, and in the except block you mention your error name from which you don't you are exempted, from which your pipeline doesn't break, because you have already specified to your system that when the particular error comes out, I want you to be exemption towards that. Okay. The fundamental approach involves encapsulating potentially error prone code within try blocks and handling anticipated exceptions in corresponding except blocks. Specific exceptions types can be called to implement tailored recovery logic. A general except block can act as a fallback for unforeseen issues. So when you are going to have an unforeseen issue, or when you're going to have a different kind of errors happening, you put that in your except block so that your code runs smooth without breaking the pipeline. Here I've got a sample try except block code. So my try block is going to have my code, which you might have chances of error prone. So once that is tried, then if any error comes out, I want you to go to your except block. So any error that is coming from your try block goes to your except block now. What happens in your except block? For example, there is an except error called as file not found error. So for example, file not found error is when you don't find a particular file in your extract data. So you want to extract data, right? So to extract the data, you need to load the data. For instance, if your file is not present, then it might error out. So to handle it, you can mention except file not found error. So this is going to handle your missing file during the pipeline or your data extraction. Then you have value error. So value error is when, for example, you try to transform a particular value in your data set. And in that, you don't have the particular value that you specified. In that case, you specify a value error where the particular error is exempted. So if there is a value error, your error is going to be left out. So you're not breaking your pipeline. And then we have got exception. So for instance, let's say I do not know any errors that is going to happen in my code. In that case, what I can do is I can just put in uh, I can just put in an exception, because this is for any unforeseen or unexpected code. Okay, so I've got a try block. I've got, so do not worry about the names I've given for error. For instance, you might even get an attribute error. There are multiple errors that you can find in your Python code, but we will cover about those kind of errors in the future series. But for now, I just want you to know that there are different errors, and these errors must be mentioned in your except block so that your pipeline doesn't break up. And then second way is granular exception handling. So we all learned about try except block, right? So what you can do is you can implement this try except block to different levels of the ETL process. So when you write your ETL code, for each block of code like extraction, transformation, loading, you can put in your try except block individually for each of these functionalities. Therefore, you're isolating the errors and all the failures are isolated, and we are allowing for the pipeline to continue processing our data smoothly. The third strategy would be to log and monitor. So whenever you're trying to run your pipeline, make sure that you implement a logging, and then once the problem is logged, make sure that it is captured for your detailed information about the exception. Why do we need to sorry why do we need to log and monitor those? Because when you monitor, you will get a rough idea about what the problem is and how you can trace it out, and in the future you can try to solve it. So you can try to integrate with the monitoring tools to track what the error is or error rates are, and then you can trigger certain alerts as well. So by this way, you're preventing any kind of pipeline breakage. Then you can set retry mechanisms. What do I mean by retry mechanisms? For example, if you have been following a data engineering series, you all would be aware about AWS Glue. What is an AWS Glue? It is a serverless ETL tool, right? Based especially for your AWS ecosystem. You have an option to set your retry numbers. So for example, if you set 3, and if there is any error happening, it would try thrice before it says that your glue job is a failure. And what are the scenarios your retry mechanisms would be useful? Let's say for transient errors. What do I mean by transient errors? There are errors that would, for a temporary kind of errors. Okay, that's what I mean by transient errors. So for example, there is a network issue. For example, there is an temporary database unavailability. In that case, you can set your retry logic, and then because you are retrying your logics, there are chances that the reattempts could make sure that your job has successfully ran. So what do I mean by a network issue or a temporary database unavailability? For instance, let's say I want to run a glue job, and while I was trying to initialize, I lost an internet connection. And when my connection is lost, the glue job is going to be failure, right? And when I reconnect, I can just, because there is a retry mechanism, the glue job would run by itself. Therefore, the transient error is skipped out. temporary database issues might come when you know, when you have an auto suspend functionalities for your database. Therefore, your database becomes idle, and because of the temporary unavailability, you can try to resume your mechanism, because once your code is trying to access the particular database, it might try to initiate at that point of time, right? On demand, it might try to initiate. So when you try to retry from the second attempt, it could work off. So that's why you need retry mechanisms. You can set data validation and error handling during transformation. So you must set out different validation checks. For example, you might try to check for your data types. For example, you might try to look for any kind of null form data records. So if you set all these kind of validation check, you can help to remove the or skip any kind of error data, or any data or any records that is going to cause error for your pipeline. And then what you can also do is, whatever the records that cause the error, you can isolate it, or you can put it to a different table for it to be manually reviewed and processed later. Then you have checkpointing and idempotency. So what is a checkpointing? Checkpointing is where, let's say you have 1 GB data set, you have processed 500 MB, and let's say you had a job failure. And then instead of processing from your first MB, that is your whole table, if you set checkpointing, your file starts processing from the last point where your data was processed. So let's say your 500 MB was processed. So now your data processing is going to start from your 501 MB data. Therefore, it is going to make sure that you are running an efficient pipeline. And then idempotency is that no matter how many times you re-execute your pipeline or your job, it is just going to give any it's not going to give you any side effects. What do I mean by side effects? Let's say I have a table with 10 records, and then I'm loading it into my data warehouse, and when I rerun the ETL job, it shouldn't load the same 10 records again to my data warehouse, because now I'll be having 20 records, but the 10 are duplicates, and I'm supposed to have only 10 records, right? So no matter how many times I re-execute my code, I just want to have just the original or the unaltered original data set. So you have to ensure that you implement checkpointing and idempotency. And then we can talk about dead letter queues or error tables. So whenever there is going to be a record that is going to repeatedly cause you certain failures or continuous processing issues, what you can do is, you can create a table, okay, for just processing your errored out records. So therefore, you're preventing out any problematic records from breaking your entire pipeline. Then the final strategy would be to implement shutdown and resource cleanup. So we all know about try and except block, right? So in the try block, you try to run your error prone code, and whatever the error is raised, we put that and we process that in the except block. And on top of this, you can have a block called finally, in which you can set your code to ensure that resources are handled properly. Talking about resources, you might be having a file, you might be having a database connection established. So why do we need to process it? Let's say I've opened a file, okay, and then I've appended few records to it, and I have to make sure that the file is closed, because there might be data leaks happening. Let's say I have database connection I have established, and if I don't if I don't shut down my database connection, I'm still going to be prone about my data leaks, right? So there are chances. So make sure that you properly close it. And the best thing about your finally block is that even if there are exceptions happening, what you can do is your finally block runs. Therefore, you're preventing any kind of resource leaks. So make sure you do a graceful shutdown, and all your resources are cleaned up properly. by combining all these strategies. So it's not just that you can just implement one strategy, you can combine multiple strategies and you can build a reliable, stable, effective ETL pipeline. All right, so these are the strategies one must follow to make an efficient pipeline that doesn't break. All right, so we have detailedly seen 5 questions today, right? How do you handle exceptions? And then we earlier saw about the usage of generators, and then we saw a few SQL code as well. So we learned about the recursive CTs, and then okay, my code is stuck for some reason. Okay, that's fine. So we learned about the recursive CTs. Then we learned about the indexing strategy. Then we also learned about the difference between the inner and your cross join. And I hope this session was very helpful to you. So if you haven't checked out on our website, do follow us at Datavalley.ai. That is our website. And you can have a look on how we can help you with your career. And important thing is we provide learning in multiple domains. So it's not just data engineering. We have streams of learning across data analytics, data science, ethical hacking, Java, Selenium, Python, C, C++, Java. So we teach multiple domains and multiple technologies as well. A full stack developer, stack developer, UI and UX designing. So do have a check on those as well. And if you haven't liked this video, drop your like. Do click on the bell button so that you don't miss on the regular updates. If you know of any fellow friends who are trying to become data engineers or aspiring to be, and if they are preparing for the interviews, feel free to share it with them so that they might find it useful as well. And then the exciting news is that we also provide our knowledgeable content across different languages as well. So we provide in Data Valley Tamil and Telugu as well. So those are the two regional languages we are focused for now. But soon we are trying to establish our streams across Data Valley Bengal, Data Valley Telugu, Data Valley Hindi, Data Valley Kannada as well. Please, feel free to check out our website at any time. And because we are the fastest growing tech company of 2025, I don't think so it is a surprise that we are, providing you with different regional languages. So we have our headquarters in US, UK, and 4 different centers in Hyderabad as well. So that is all for today. I hope this session was very helpful to you. Feel free to give a ring to our colleagues at Data Valley. They will check up with you and they'll make sure that how they can benefit you and help you with your career goals. So that is all for today. Thanks for watching this video. I hope this video was very useful to you. And this is Franklin signing off. Thank you. Hope you all have a great day. Bye bye. Take care.